Hi, welcome to the 3D Pen. Lately I have been making a series of videos on the 5 Platonic solids. Interesting thing is that 3 of the 5 shapes are all made from the same equilateral triangles. The tetrahedron, the octahedron, and the icosahedron. And what determines which one of them it is going to be is the angle with which you join the first 2 triangles together, which is called the dihedral angle. If it's 70 degrees, or 109, or 138, the dihedral angle alone determines that you will need 4, or 8, or 20 triangles to enclose the shape. We have already done the tetrahedron and the icosahedron. The links are in the description. So let's look at the 8-sided guy, the octahedron. As I already mentioned, we'll need to make some equilateral triangles. As the name octahedron suggests, we'll need 8 of them. And they will come together at 6 corners, called vertices. But don't make 8 separate triangles just yet, because we need only 12 sides and these have 24. Since the dihedral angles matter so much, we'll use our handy angle support tool, which I strongly recommend you make for yourself. It comes in super handy for many projects, even if you never make Platonic solids in your life. The video on that process is in the description. The dihedral angle of octahedron is 109 degrees. So I will set the angle between my work surface and the support tool that will hold the rest of the project at 109 degrees and make sure it stays that way. Now we are ready. Make the first triangle, and when it's cold enough not to deform, take it off the surface and tape it to the angle support. I have taped another blue pattern to the angle support just so you can see better how things align. This corner is not taped enough. I may need to tape it better going forward. With the second triangle, we'll need to make just 2 lines to complete it, working from the corners onto the work surface. Here, face 1 and 2 joined at 109 degree angle. This is the point that decides it's going to be an octahedron when it grows up. Now let's tape this side better than the first time. And maybe fix the alignment of the blue triangles a bit. The next 2 lines will make the face 3. Perhaps I'll tape the blue triangles to the support separately so it's not so floppy. I need just 1 line to finish the face 4. But if I make the whole triangle again, I can complete the face 5 in the same step. tape will be in my way. Let's move it up a bit. Okay, phase 4 done. And phase 5 done. I am 2 lines from done. Phase 6 done. One line from done. Done. If you are just doing your geometry homework, you are done now. But as usual, there is fun to be had by adding some design into those 8 faces. You can of course use all the variations in the tetrahedron and the icosahedron videos. These are all the same equilateral triangles, remember? Here's a twist on the triangles within triangles pattern from the tetrahedron video. Except I am leaving out the 4 central triangles and putting even smaller triangles into the ones I am keeping. I am adding the long main triangle sides only when I flip the project onto the next side. And I do that the first thing after the flip to attach the project securely to the work surface again, to add the next side. Octahedron is a relatively tight shape, so after you finish the phase 4, you will have less and less room to get in with your pen. So it works better for this one to make the 2 halves first and then join them together. First just in the 4 corners to make sure it all fits snugly together, and then do all the other joining points. And here we go. Here is the other design from the tetrahedron video. This time I'm leaving out the bottom third, which will make it into kind of a 4-pointed star on each side. Otherwise, proceed the same way as with the other one. Until then. Of course, you can also do it exactly the same way as in the tetrahedron video and get this. Or this. So, here are the 4 octahedron variations you can try before inventing some of your own. I just think the openings add an interesting mix of the filled and unfilled areas. And I know what you are inevitably asking. Can I have my octahedron completely solid? Sure you can, if you are willing to put in the work. But that will have to be another video. So until then, go and make something.